We would like to add some sort of environment to keep general information on the block for various processing, such as the block name, style sheet location, and so on. We can represent our environment as a record data type and build it from user input. The user input can be from command line arguments, a configuration file, or something else. After filling this record with the requested information, we can pass it as an input to any functions that might need it. This is a simple approach that can definitely work for small projects. But sometimes, when the project gets bigger and many nested functions need the same information, threading the environment can get pretty tedious. There is an alternative solution to threading the environment as input to functions, and that is using the reader_t type from the MTL or transformers package. Reader_t is another monad transformer like except_t, which means that it also has an instance of functor, applicative monad, and monad trans. As we can see in the definition, reader_t is a new type over a function that takes some value of type R and returns a value of type MA. The R usually represents the environment we want to share between functions we want to compose, and the MA represents the underlying result we return. The M could be any type that implements monad that we are familiar with. Usually it goes well with IO identity. Depends if you want to share the environment between effectful or uneffectful computations. Reader_t carries a value of type R and passes it around to other functions when we use the applicative and monad interface, so that we don't have to pass the values around manually. And when we want to grab the R and use it, all we have to do is ask. For our case, this means that instead of passing around env, we can instead convert our functions to use reader_t. Those that are uneffectful and don't use IO can return reader_t with identity instead of just A, or the simplified version, which is reader_env A. And those that are effectful can return reader_t with IO instead of IO of A. Note, as we've said before, functor, applicative, and monad all expect the type that implements their interfaces to have the kind type to type. This means that it's reader_t rm which implements these interfaces. And when we compose functions with apply or bind, we replace the F or M in the type signature with reader_t rm. This means that, as with either E when we had composed functions with the same error type, so it is with reader_t rm. We have to compose functions with the same R type and the same M type. We cannot mix different environment types or different underlying M types. We're going to use specialized version of reader_t that uses identity for M called reader. The control monad reader provides this alias. If the ideas behind reader_t is still a bit fuzzy, we can get a better understanding of how it works by trying a few exercises. For example, we can take a function from the applicative or monad interface, for example lift_a2, and specialize its type signature by replacing F with a concrete reader_t, such as reader_t in the IO. Lift_a2 takes a function that takes A, B, and returns a C. It takes f of A, f of B, and returns f of C. We drop the constraints because we have a specific version. Then we replace this, replace that, and in that we get a specialized version of lift_a2. It takes a function that works on A, B, and returns C, and lifts it to reader_t, so we can get reader_t env A, reader_t env B, and use a function on them and get reader_f C. Reader_t was a new type over function from R to MA, so we can unpack this new type and replace it within a function. So in our case, we have a function from environment to IO of A, and we can replace it in our type signature for lift_a2. This one is IO of A, IO of B, IO of C. Now we can try to implement this specialized version. We have some functions that we apply to A and B. We have a function A, function B, and environment. So at the end, we can return IO of C. We apply environment to function A to get IO of A. We apply environment to function B to get IO of B. Then we use lift_a2 to apply this function on IO of A and IO of B to get IO of C. And notice how the job of our specialized lift_a2 for reader_t is to supply the two functions with environment and then use the lift_a2 implementation of the underlying M type, in our case IO, to do the rest of the work. Does it look like we are adding a capability on top of a different M? That's the idea behind monad transformers. So how do we use the reader? Instead of defining a function like this with explicit env, we define it like this, using a reader. Now that our code uses reader, we have to accommodate that in the way we write our functions. We could pass environment as a parameter, and then we would pass it to all the other functions like build index or convert file, for example. But now we can switch to using reader, and note how we need to thread the environment to the other functions that use it. We use do notation now. Instead of threading the environment around, we compose a relevant function, build index and convert file. We use the type class interfaces to compose the functions. Note how we need to fmap over build index to add the output file we needed with the tuple, and how we need to use traverse instead of map to compose various reader values convert file will produce. When we want to use our environment, we need to extract it from the reader. We can do it with the following function, which yanks the R from the reader when we extract it with bind. Let's use environment in convert file. We can pass it and use it as a normal parameter, or we can use it as a reader. We use ask to get the environment, and then we pass it along to convert. And note that we didn't change convert to use reader, we pass it as a normal parameter there, because convert is a user-facing API for our library. By providing a simpler interface, we allow more users to use our library, even those that are not yet familiar with monad transformers. Providing a simple function argument passing interface is preferred in such cases. Similar to handling the errors with either, at some point we need to supply the environment to a computation that uses reader and extract the result from the computation. We can do that with the functions runReader and runReaderT. These functions convert a reader or reader t to a function that takes R, some argument. Then we can pass the initial environment to that function. For instance, let's look at convert directory. If we add environment here as an argument, and we want to pass it using a reader to the txt to render HTML file function, we can run the reader on that function, which means it just converts it to a function, and pass it an argument normally. Sometimes we may want to modify the environment we pass to a particular function call. For example, we may have a general environment type that contains a lot of information and functions that only need a part of that information. If the function we are calling are like convert and takes the environment as an argument instead of a reader, we can just extract that environment with ask, apply a function to the extracted environment, and pass the result to the function like this. So in the outer function, we get the environment, then we use the function extract small environment to get some smaller piece of the environment and pass it along to this inner function, which wants a smaller part. But if inner also uses a reader small env instead of argument passing, we can use runReader to convert inner to a normal function and use the same idea as before. We get the environment with ask, then extract the smaller part of the environment, and then runReader with a smaller environment. This pattern is generalized and captured by a function called withReaderT and works even for readerT. It takes a function that modifies the environment and converts the readerT with one environment to readerT with another environment. We can see it concretely with our example. We pass the extract small environment function directly to withReaderT. So the function extract small env goes from bigger environment to small environment, and then we go from reader of small environment to the reader with big environment. And note the order of the environments. We use a function from a big env to a small env to convert a reader of small env to reader of big env. This is because we are mapping over the input of a function rather than the output. And it's related to topics like variance and covariance, but it's not terribly important for us at this moment. One thing that we have not talked about yet is using our environment in the convert function to generate the pages we want. And actually, we don't even have the ability to add style sheets to our HTML DSL at the moment. We need to go back and extend it. So let's do all of this now. We should extend our HTML library to include headings and 3 functions: title, style sheet, and meta. Let's update HTML instead of just title. Head is going to be another new type. And now HTML is HTML element, which contains head and a body. We don't have a way to create HTML yet. Let's start with the simple one with the title, which creates a simple head with just a title. We can also create style sheets, which takes a file path to the style sheet, and meta tag, which takes a name and a content. To make it easier for us to create new empty heads and combine different heads together like we did with other tags and structures, we can create a monoid instance and a semigroup instance, which simply creates an empty head or unwraps heads to combine them together into one. And we should not forget to update the export list. We should fix convert and build index to use a new API. Note that build index should return a reader. Let's update the convert function, which convert markup documents to HTML. Now this is a more proper HTML. It has a head, which has a title, which contains the block name from the environment and the title of the document. It also contains a style sheet, which we also get from the environment. Article itself stays the same, but now we add the website title to it. So from each page, we can go back to the index.html by clicking on the block name, which we also got from the environment. Then let's fix the build index in the directory module. We need to use a similar API. We need to update how we create the HTML. First, we need to get the environment. In this case, we make this function work with the reader. We can extract the environment using ask and then use this to create an HTML title using block name and style sheets and combine them together using append operator. Last, let's create a command line parser for environment. Attach it to the convert directory command and pass the result to the convert directory function. Let's go to command line options module. Convert directory should take an environment. And we should adopt the parser. Let's start with the parser for the style sheet. We pass it as a style option, which is a file name for the style sheet. And for the value example, we can use the default environment we declared before. Then we can create a similar parser for the name, just name option for the block name, and combine them into a single parser for the environment. And then we hook it up to the convert directory parser. One of the last things left to do is to get the environment out of the parsed options in the convert dir and pass it to the function as a simple parameter. We broke the convert API in multiple places, so we need to fix it in the process and convert single functions as well. In this case, we're not gonna parse anything, so we can pass along the default environment to the convert function. And also we broke the title and use a head instead, so we just replace it with strings in this case. So which version do you like better? Manually passing arguments or using reader? To the author, it's not clear that the second version with reader is better than the first with explicit arguments passing in our particular case. Using reader and reader T makes our code a little less friendly toward beginners that are not yet familiar with this concept and techniques. And we don't see in this case many benefits. As programs grow larger, techniques like reader become more attractive. For our relatively small example, using reader might not be appropriate. It's included in the book because it's an important technique to have in the arsenal. But it's also important to weigh in the benefits and cost of using advanced techniques, and it's often better to try and get away with simpler techniques if possible. In the next part, we'll write some tests and write some documentation.